Hi, welcome here. So my name is Adrien Goeller, and I'm working for RTE. Here I will talk to you about empowering grid maintenance with Phlowers. So I think here in this room we have heard about strange things because we heard about sweets. The grid is sweet. We heard about relife, and now we are hearing about flowers and power lines. I don't know. Let's see. My purpose here is to talk about men and women which are building the grid, which are repairing the grid and maintaining the grid. So a little about RTE. RTE is a French TSO with three main missions. So operate the power transmission system, optimize the French electricity system, and inform the public decision. And to do that, we have three main professions: grid development, grid operation, and grid maintenance. And in fact, maintenance receives the least media coverage, but it is crucial for grid operation and cost control. So as a TSO, we have a legacy network with 100,000 kilometers of lines, with a very large number of supports. And an interesting figure is that 1/3 of the network has an average age of 67. So we are doing some things. In France, RTE is publishing grid development plans, and this year it highlights rising investments across all chapters for power line replacement, for increasing capacity of existing power lines, and reinforce the 400 kV network. Because we have to deal with several things: congestion risks, heat waves, it happens, and electric transitions. So those different reasons are impacting, in fact, the maintenance on all lines. Because for RTE, maintenance optimization is crucial for several reasons. First one is to maximize line availability for network operation. Those interventions can be tricky due to factors such as machine sizing, for example, due to the difficulty. I put some image just to figuring out. Interventions have a logistical cost for the network. We have to avoid unplanned actions. So the goal for maintenance is to guarantee the security of people working on the line. The different interventions have to be prepared and sized precisely. There is a control of clearance with surrounded objects and the on-the-field measuring. So now here is for the challenges. Perhaps let's do physics now. What is the impact of cable temperature? And why we have to deal with cable temperature? In fact, here there is a line with three spans. So if I have a little more wind, the line goes up in that specific span. If it's getting warmer, the line is lowering. And this is the same with solar heating and transit. So the problem is if I have objects surrounding the line, the cable can expand with weather change and may violate clearance with surrounded objects. So the interesting thing is that, in fact, maximum temperature is a good proxy for distance in the world of maintenance. So now I know the cable temperature, and I want to make some mechanical computation. We can compute geometrical position or clearance. Let's imagine that this object here is too close to the line. So we can, some example use cases. We can do tensioning on the span, but we have to calculate the length, the length to pull the section. In fact, we are not pulling here, but it was too difficult to do that. Another use case is the load I can put on the cable. So we have to make calculation to have access to forces or torques on the hanging point of the cable or on the pylon. And the last one is I want to change my support, so I have to dimension a crane to do that. So I have to know the force that the crane is able to hold. So that's why we initiate Phlowers. Phlowers is a GitHub organization, and this is a collection of open source tools for physical studies on power lines. So Phlowers is, there is two parts. Libraries part, where there is two libraries, one dealing with mechanical issues, and the other with the thermal issues. And the other part is an application part, where you can find Stellar, an application based on MechaFlora, and DNAP, which is not actually in the repository. You can go to GitHub. But this is an application based on OHL, which is the thermal part. So perhaps the question could be why Phlowers is open source. In fact, you've heard perhaps at other talks that open source is in RT DNA, and we have starting mainly with power system tools, and now we have challenges in asset management. So we are doing, we are trying to do the same things. Another point is that asset management is late on OSS tools. So here we want to offer a transparent and controlled algorithm. We know because we use commercial software, and they are hard to use, especially for on-the-field people, which has they have not the time to go, and they prefer to go on the line than to perform complex study on the computer. So that's the reason we want to make it open source, and this is there is a 3 active repository, RT only a contributor for the moment, and it is driven by internal uses for the moment. So let's dive into the stack from the libraries. We choose a very classical stack because this is about scientific packages. So we choose a SciPy stack with a core in a pure NumPy to get C performance. The libraries are open for additional models or solvers because we have rules, but we know that every TSO or DSOs have perhaps others. We make the user input customizable for users' data. And we try to have an API easy to use for notebooks. So one specific point is that we wanted to use the Python into the navigator to have offline applications. So those libraries are Pyodide compatible. Pyodide is a framework to allow to execute Python in front-end code. So first, I will introduce ThermoHL. You know perhaps about DLR. Here, this is the same equations of DLR. This is a classical power model. So you have, if you have wind, temperature, solar heating, transit, and the line parameter, you can have access to the cable temperature. If you reverse the equation, you can have put the maximum temperature in input and have the maximum transit in output, which is called also ampacity. So our package is able to perform cable temperature calculation, but also ampacity calculations. In fact, there is several states in the cable behavior, and we can compute a transient state or steady state. We have also models. We are dealing with multi-temperature inside the cable, so we can access to surface temperature or core temperature or perhaps others in the upcoming models. So here, previously, it was R&D project. It was industrialized in 2021 as part of our DLR project. After was an internal common software with a R wrapper, and it was used behind several studies or processes. So the interesting part here, the open part, is that we have 4 models inside, but it's open to additional ones. We have 2 equations, 2 different equations, and it's also open to additionals. So what's next? The roadmap here. This is, in fact, we open sourced recently, but this is a product we are using since 4 or 5 years. So next, we have not a very a roadmap, with very big steps. So all small steps, in fact. Let's talk about the Phlowers package. Here, this is slightly different because there is a core scientific package inside, but we wanted to add a data management layer and also to have visualization tools inside and to be user-friendly for the API, because the goal we want it's that Phlowers have to be the user's flagship for line data exploration. I mean, in the line data. What we have here, it's the different main parts we are building, because we start MakerFlower on January this year, and we target a beta version in January next year. The interesting part on those blocks is that the multi-scale models are open to additional. The user API is designed to be notebook ready. All the data parts can be easily customized to fit to the user's data. And we are dealing with a lot of features used internally. So we are dealing with section parameters. You can put some ground points, some obstacles of several types. You can change state with changing weather conditions, but also you can perform cable manipulations. So some extracts. So we have a doc on read the docs. We have also you can try on phlowers.github.io /Phlowers notebooks if you want, and those are extract of those notebooks. So an interesting thing here, you can see that we can do multi-section visualization and calculus. And you can see here, for example, change state change with wind input by span. So now we've seen the libraries. Let's dive into the application. So Stellar is basically an application based on MakerFlowers. And the goal here of this tool is to be the reference tool for maintenance operations. So here, this is a tool of simulation. It's a simulation tool of sections with obstacles, ground, climatic condition, cable manipulation. And the idea here, it's in fact there's this is a complex computation. Data is complex, but we want that this software is easy to manipulate. So Stellar users are on-the-field people for construction preparations, on-site verification, or they can perform studies for different users and potentially expert users. Stellar is built on the top of our experience returns from users on internal software since a long time ago, in fact. And the idea for the development, there is two main points. One I already mentioned is to have a user experience enhanced to simplify the usage of a complex tool. And the other is to provide an offline mode, because if you are here somewhere or somewhere here in the mountain, perhaps you can't connect to the server, so you have to be offline. Here we start the project in April this year, and we target a beta version January next year. The interesting part here is that for input, we provide a way for a user to load users' data the more easily we can. The studio is the main part of the software, and we are designing the API for custom access because we want also to have tools designed as plugins. So if you are developing a plugin, you want to have access to Studio, you want to have access to study management, which is holding all the different objects. So we have the philosophy to welcome new development inside, in fact. Some exclusive preview images. Some people in RT never saw that image. So here's a stellar welcome page. Here are the image from the section Study Explorer, the studio. With you have navigation options here, the tools plugin zones, the state, you can change state with those tabs. You have a 3D view, and all the graphs are dynamic. Are in practically we are based on Plotly, which is a package which is providing those dynamic graphs. So last but not least, an overview on DynUp application. This is a little. It is not the same than the other, which are currently in active development. Here, this is a software. The goal of DynUp here is to provide cable temperature data for past weather, short or medium-term weather, and long-term climate evolution. So here the users are very different users: grid operation, maintenance, grid development, expertise. This is a little specific because we have released a Data Lab first version internally in 2020, and we have already 5 years of usage, and we are using it. We are adding. We added more and more use cases, and now we are launching a new industrial version. So a feasibility phase in January next year. Why? Because there is some difficult point to solve. This is about weather, so we have to deal with very high volume database. We want to work on a calculation API system, and for the calculus, this is already done with term or a shell. So some example from the Data Lab version, what we target to do, what we currently are doing with that data. So first, we can plot some dynamic maps with weather and ampacity or cable temperature by span. So this is very interesting when you have to analyze some specific situation. We can have access to time series for ampacity or cable temperature. You can see here by section or by span. And also we have users who wants to use it for decision, and they want to perform statistic on a very high volume of data. So several years, for example, on with a multi-line analysis on a zone. So those are the different use cases we provide with the Data Lab version. So to conclude, Phlowers is a collection of open source tools for physical studies on power line. We are actively developing it. We want to help asset management and maintenance with open source tools. And with Phlowers, we are interested, in fact, in hearing from people who are interested in these themes. For example, do TSO or GSO have the same needs than us? So our aim is that Phlowers become a collaborative coding hub and a thriving community around power lines. Here, QR code which leads you to the GitHub page. There is a Slack, there is a read the doc, there is notebooks. So thank you for your attention. Yes.
Thanks. I have one question. Have you validated or plan to validate the mechanical and thermal models with field sensor measurements? I mean, the SACs can be measured 5, 6 different ways. Temperature sensor, conductor temperature on surface is easier to measure than the core temperature, but you can still use fiber optics to do that. Do you have plans to do so or have done it?
Thank you. Thank you for the question. So in fact, that's not my part because I'm not R&D. But I know for mechanical parts, we are making comparison with reference software, commercial software we use, and we are based on that for the moment. Because when you are on the field, there are some parameters which can affect your measure, and this is not so. We are targeting to have the same performance than commercial software. For the thermic part, there is some sensors on some lines, and I know there is some comparison, but I'm not aware of all. Thank you. Other question?
Merci. Thank you for the presentation. And I'm sorry, I have a very basic question. Maybe you can educate me a bit here, but as I've been also working on the DLR space, I still don't see what's the obvious and basic use case and problem we try to solve here. Because with DLR, I see how we can, I see the goal we try to achieve with operational system to operate closer to limits, with the market system to make sure also we optimize the capacity calculations. With the asset management use case, I don't see it, so can you?
Right. You about thermal or about everything? About mechanical too? Yeah, so a lot of different things. In fact, for example, here you have people which are working on the pylon, so they have to prepare the intervention. So for that, they have to simulate the line in the state. For example, imagine they are on some with a temperature on. You have to so the mechanical tools can put a simulation, can make a simulation of the line in the same state that you have, and it gives access to some hidden parameters. For example, the force you can have on an insulator. It could imagine just a case where you are breaking the arm of the pylon because you have too heavy weight. So the idea is to simulate the section, the span, the line, the cable. And for cable temperature and asset management, the idea is to use cable temperature as a proxy to see what's happening on your line. If your line is at with DLR, if your line is very close to the limit, it can age the line. You can have an aging process, and so you want to do predictive maintenance, for example, because you know that this line is more used than another. I don't know if I. in fact, there is a lot of different use cases. For example, here you have trees. You don't want to engage the clearance with the distance with trees because you can provoke fire, etc., etc. So with this tool, you can simulate the cable, the lowest cable possible, and after you can make a rugby balloon, we call it, and so you can define the zone where you have to cut the tree, for example. This is another use case. There is a lot of use cases behind. Other question? Yeah.
Yeah, thank you. I'm just curious, when you do these calculations, you of course need some input data about your lines, about ground objects. Is there a plan, or is it already in place that you kind of store it in a central way and you can import it, or is it more like you do a calculation and then you have to kind of collect your data that you need?
Yeah, in fact, we have already some file formats for that. We are working on those file formats for the data because there is several way to express that. For example, you can just have the first pylon and after the distance and angle with the second and distance and etc. etc. But you can have a GPS position or other system coordinate. So this is, in fact, inside the data management. That's why there is a data management. There is parsers to ease users, different users with different format to input the data.
Thank you.
Other questions? No? So, thank you.